say we talked about our monomials. We started with that review practice that we started with, and then we jumped to talk about what is a monomial. Then we were looking at what are the degrees of monomials. What did we find for the degree of this monomial for our first one? 2. 2. How did you come up with that? So each of those variables, as long as they don't, or if they don't have an exponent, we know the exponent is really just a hidden 1 in front of it. So if they both have a 1, we can add those together and we get 2 for the degree. What about the second one? 9. Once again, we have y has an exponent of 8. Z doesn't have an exponent, so we know it's going to be a 1, so we add those together to get 9. Good. And then C? 0. Because it's just a coefficient, there's no variable, it doesn't have an exponent. Wow. Are we okay with this?
Yep.
Cool. So that's how we find the degree for our monomial is. Now we're going to talk about what a polynomial is. So the word poly, or the prefix poly, just like monomial means 1, binomial would mean 2, trinomial would mean 3, a polynomial just means multiple. The word poly means multiple. So if you think of a polygon has multiple sides to it. What's another example? Polymorph means to transform into different shapes. So poly, that little prefix means multiple. So what this means is you're taking multiple pieces, multiple monomials, and putting them together. So each monomial is going to be split between, it's going to be the sum of all of them. So they're either going to have an addition sign or a subtraction sign between each term. So for this example, this is a monomial, this is a monomial, this is a monomial, this is a monomial. But together, all together, they equal a polynomial. Okay? So 3x to the 4th plus 5x squared minus 7x plus 1. That's all together is a polynomial. Are we okay with this? With the definition so far? So this polynomial is in standard form. Here, let's put this away. So standard form is when we write the polynomial from the highest degree to the lowest degree. So if we look, my highest degree exponent is 4, and then I go to 2, and then I go to 1, and then I go to 0. So standard form, you always write from highest degree to lowest degree. Anytime you're writing a polynomial, it's best to put it in standard form. It's just the nicest way to write it. It's typically the easiest to work with in that form. It doesn't have to be in standard form. You could rearrange all of these and it'd be fine, but we typically like to write it in standard form. Then if you're looking for the degree of a polynomial, not just the degree of a monomial, the degree of a polynomial is going to be just the degree of its highest monomial. So 4 was our largest degree we have, so that would be the degree of our entire polynomial as well. It's just you take the highest. Yes, what?
But it's still like all don't have an
If they all don't have an exponent, so let's say we had 3 plus 7 minus 11 plus 1, something like that. What would you do with this? Can you combine all these terms?
Yes.
So that would give us like what? 10 negative 1 plus. Okay, that gives us 0. What's the degree of 0? 0. So even if you got like 28 as your answer, your degree would still be 0 because 28 doesn't have an exponent or doesn't have a variable to it. So if you don't have any variables or don't have any x's, it's all just been combined with 0. Good question. Any other questions before we continue at the moment?
How was your day?
It's going well. So polynomial means multiple. Monomial is each little piece inside of that polynomial. Now, depending on how many terms we have, depending on how many terms we have inside that polynomial or how many pieces, we have different names for them. And there's a couple ways that we can identify them. There's a couple we can identify by how many terms they have, or we can identify by the degree. So there's 2 ways we can name these polynomials. So over here, I know this is kind of a confusing chart, I have just some random polynomials, just random examples of polynomials. We have the degree listed of each of these polynomials. So 6 has a degree of 0, 5x plus 9 has a degree of 1, this one has a degree of 2, a degree of 3, and a degree of 4. Once again, it's always that highest power is your degree for the entire. If Do you need to go see the nurse? Or I guess she's not. She's probably not here today. Okay. I'm sorry. I do feel better. So we can name based off of two ways. So the first one is you can name the polynomial based off the degree. Depending on what the degree of the entire polynomial, you can give it a name. So if it has a degree of 0, we call it a constant. So just like we always have like 5x plus 11, we always call that 11 the constant. Any just normal plain old number is going to be a constant. If it has a x, just a degree of 1, it's a linear polynomial. Just like we talked about linear equations, anything that had a degree of 1 was always linear. Always had that same pattern. If it has a 2 as a degree, we call it quadratic. So these ones were the ones that had the big U shape that we looked at earlier in the year. We'll talk about more of those in the future. If it has a 3 as its degree, it's a cubic. You'll learn more about those in Algebra 2. And then the last one's called a quartic, which we don't run into those very often. You kind of talk about those in Algebra 2 as well. But you could go farther, and there's like a quintic and a heptic is the next one. But for right now, these are just the ones we're worried about. So if you have the degree, you can name it. Another way you can name them is using the number of terms. So this one just has a single term, so it's a term of 1. This one has 2 terms, 3. This one has only 1 term, and this one has 3 terms as well. So based off the number of terms, you can also give it a name. So a single term, we talked about earlier, was a monomial. If it has 2 terms, it's called a binomial, because if you think like a bicycle has 2 wheels, or we have binocular vision, we have 2 eyes. Bi means 2, and so it's a binomial. Trinomials, like a tricycle has 3 wheels, is going to be for 3 terms. You could technically go on if it had 4 terms, 5 terms, 6 terms, but we don't worry about those. So there's 2 ways of naming them. You can either name them using the degree, or you can name them using the number of terms. Either one is correct, and you can use them interchangeably. It's just really whatever you prefer. It's just being able to recognize what they're talking about. If I said a trinomial, I want you to know that I'm talking about a 3-degree polynomial. Or not a 3-degree, a 3-term polynomial. But if I said a quadratic, I want you to know that's a degree 2 polynomial. So, I know this is a lot to soak in at the moment. It's a lot of new words. It's a lot of random words. But the more we work with it, the more we use them, it will become easier to use. So don't let this necessarily freak you out at the moment, or don't necessarily feel like you have to memorize everything on that chart. These are just some examples just to help us become familiar with them. And we'll become more familiar as we start using them more and more. The main thing we're going to talk about in the future is trinomials, quadratics, and binomials. These are the main things we'll talk about. We already talked about linears earlier in the year and constants. But quadratics, trinomials, and binomials is what we're going to focus on later on. Are we okay with this so far? Okay. So the main meat of today is we're going to talk about adding and subtracting polynomials. Earlier with that warm-up, we had 2 binomials. We had 15x plus 5, and we had 20x plus 6. And we combined those polynomials by looking at, okay, what were my terms I had? We saw we had 15x and 20x. We combined those to 31x, and then or 35x, and we had 6 plus 5, and we combined those to get 11. So the same thing works for this. When you're combining polynomials, all you have to look for is those like terms. So what terms have the same variables? What terms have the same exponents to them? And just combine them together. So if you were to combine this first one, what like terms do you notice?
5r to the third, 6r to the
So we have 5r to the third and 6r to the third. If we were to combine those, what would we get?
11r to the
11r to the third. Because we're only adding and subtracting, we don't have to worry about combining the exponents or anything like that. It's just adding and subtracting like terms. We don't worry about multiplying or anything like that. And then 8 plus 3 will give us 11. So this is 11r to the third plus 11. Are we okay with this? See if you can do that second one on your own. See if you can notice what are the like terms. How would you combine them? Main thing to notice though is we have a negative. So what would you have to do if there's a negative in there? So take a moment, see if you can subtract those 2 polynomials. talk about this. What do you notice about this problem?
There's many.
We have a couple different exponents. Looking at this first one, what is that first term? It's 6x squared. Is there more to it? Y to the third. So that whole thing, all of this being multiplied together is one term. So 6x squared, y to the third is all one term. What's my first term of my second polynomial?
3x squared.
3x squared y. Are these like terms? Why or why not? What are we thinking? What's different about them?
There's not a number of the y.
So this one's y to the third. This one's just a single y. If they have different exponents, does that make them different, or does that allow them to be like terms anymore?
I don't know. You tell me, you're the math teacher.
No. So variables with different exponents are no longer like terms. So because this is 6x squared y to the third, and this is 6x or 3x squared, just a single y, they're no longer like terms. So these actually can't be combined together. So we can just leave this as 6x squared y to the third minus 3x squared y. Once again, the reason I'm subtracting is because we have this big subtraction. So both of these terms are being subtracted.
What about plus 7?
Can we combine those?
Yeah.
So we have a plus 7 and then minus a plus 1. What would that give us? 6. Okay. So this would be the most condensed form of this polynomial. We can't combine anything else. We can't bring anything else together. Are we okay with that?
Yes.
Okay. Cool. All right. I want you to try this one. Easy. I would recommend writing it down on a piece of paper. Look for those like terms. Look for those exponents. Look at those variables. Which ones are the same? All right, let's talk about these. What like terms did we see in the first one? So we had a 3x to the 6 and a 5x to the 6. So because we were adding these together, we had 3x to the 6 plus 5x to the 6. We do that. We can combine this to be 8x to the 6. Do we see any other like terms?
5x.
One thing we'll want to remember though is this is negative 5x and then 18x. So 5x plus 18x. Good. So 8x to the 6 plus 13x is your first one. Let's talk about that second one. What like terms do you see? What was that, Colton? See any like terms? So we have a 4x squared. This is like terms of x squared. So it's 4x squared minus x squared gives you a 3x squared. Do we see any like terms with 6xy?
Yeah, 7x.
So this is minus a negative. What happens when we subtract by a negative? It adds. So 6xy plus 7xy
13.
gives us 13xy. Once again, it's only like terms if they have the same variables and the same exponents. So these ones are not like terms because they have different exponents and different variables.
Negative 8y plus 2.
So negative 8y minus 9y gives us negative 17y. Once again, these aren't like terms because this one has an x in it and this one doesn't. So always look for those like terms. Are we okay with how we determine this? How we split some of them up? Bradley, was that helpful?
Yeah.
Joe, if you need to use the restroom, you can get that. All right. Now we're going to take it up just a little bit. So rather than adding or subtracting two different polynomials or two different binomials or trinomials, whatever we have, I just have this whole polynomial here. What we want to do is we want to simplify it. We want to look for what are all the like terms within this polynomial that I can combine together. And then I need to rewrite it in standard form. What did standard form mean again at the beginning that we talked about? What made a polynomial in standard form? So standard form, we look back. Standard form was when the degree of the polynomial, standard form is when it was in order from greatest to lowest degree. So we start with the highest degree, then we went to the next lowest, and then we went lower and lower, all the way from highest to lowest. So once we get these organized, we're going to have to rearrange it so the highest degree comes first, and then we end up with the lowest degree. So we're going to do the first one together. So what are some like terms that you notice in this whole thing?
5k,
So we have 2k squared and 5k squared. How can we combine that? So 2k squared plus 5k squared, so that gives us 7k squared. Do we see any other terms? Like terms? So 3 and negative 7 gives us a negative 4.
So you have negative 3k.
So a negative k and a k, 3k to the third. These ones don't have any other like terms to them, so we're just going to rewrite them as negative k and then 3k to the third. So I simplified them, I combined all my like terms, and now I just rewrote the ones that didn't have any like terms. Now, the last thing we want to do is we need to put this in standard form. So that means we need to go from highest degree to lowest degree.
So 3k3.
So 3k to the third is my highest degree.
Plus 7k.
Plus 7k squared is my next one.
Minus 4.
So which one has a higher k or higher degree?
Oh, okay.
So negative k has a higher degree, and then minus. So this would be your simplified polynomial in standard form. Combined all those like terms that we had, then rewrote it from highest degree to lowest degree. See if you can do that second one. I'll make it a little bit bigger so it'll be easier to read. All right, let's talk about this. What like terms did we see first?
14, 8, 4,
So 14 h to the fourth and negative 9 h to the fourth. We can combine that to 5 h to the fourth. What other like terms did we find?
Plus 3.
So the rest of these terms we didn't have any other like terms. That was the only ones we could combine. So from there we just had to rewrite it in standard form. So from highest to lowest, 3.
Oh, keep on going.
Are we okay with this problem?
What's wrong with you?
All right. So I'm going to give you one final thing to do. All right. I want you to turn to your partner, or who's ever sitting next to you, or someone sitting nearby. I want you both to create a polynomial. So both create your own polynomial, and then I want you to add them together, and then find the degree in the standard form of that final polynomial. So both write down a polynomial, combine your polynomials together, and then find the degree. Well,